Hi, today we'll be creating something based on this animation. We're going to have a grid with the same number of rows and columns, and we're going to set this number to 9 for now. We're going to increase it later, but for now we don't want to risk a browser crash. We're also going to compute the total number of cells on the grid, and this is going to be n times n. Everything is going to be within the body. We're going to have a loop, so while p gets decremented and is still positive, we create our cell elements. And before we move on to the CSS, we're going to set in a style attribute on the body that n value as a custom property which we pass to the CSS, so we can use it for grid template and stuff like that. And since I mentioned grid template, we're of course going to set display grid. We're going to have that grid template property, and since we want to have the same template for both the rows and the columns, we're going to set it first as a custom property. So this is going to be repeat. We're going to use that number n of rows and columns, okay, and for the cell size, which is going to be both the row height and the column width, we are going to use calc and something almost as big as the smallest viewport dimension. So let's say it's going to be 80% of it, divided by that number n of rows and columns, and we're going to use that both as the row template and the column template. Okay, so having done this, we can move on to styling the cell elements. So we're going to have a background, and this is actually going to be a radial gradient, and let's say it's going to be current color to transparent. Okay, and here let's say we're going to want to have place content center, and this should put our grid in the middle. It only seems to do so horizontally, and that's because at this point the body still takes the height of the content, which is the grid. So we need to explicitly set a height on the body, and we're going to set it to the viewport height. This gives us an ugly scroll bar, as you can see right there, and to fix that we are going to zero the margin, because that scroll bar is created by a margin on the body, and if we zero it, that solves the problem. Okay, now next thing, we're going to want to prettify that gradient a little bit. So we are going to use as the background color, we're going to use the second color in that list of colors at the beginning, at the top of the SAS. And we're going to set the current color, so color, we're going to use the first color in that list. So it's going to look like that basically. And let's say that we're going to use a progress for this radial gradient. Let's register that. So property, we're going to register it first, p, and this is going to have syntax. This is basically like a type, and we're going to use length percentage. So this supports length percentages and calc combinations. So we're going to have also initial value, let's say -1 pixel. Inherits won't be necessary, so we can set it to false. Maybe it even helps with performance, hopefully. So now here we'll be using that progress, and here we're going to have calc +1 pixel, so it's going to look something like that. Okay, now that doesn't look like much, but if we animate it, so let's say we're going to have keyframes, and we are going to start, so at 0%, we are going to have a p-value of 100%. Let's maximize this for now. Let's set an animation duration, let's say 2 seconds, and we can set an animation here now. Animation, p, that animation duration, linear, infinite, let's see it. Okay, you can see it's starting to look like something, but we're going to want to have a delay for those, and in order to create that delay, we're going to need column indices and we're going to need row indices, and we're going to set those in a style element right here in a loop. So for let I going from 0 all the way up to n, increment this I, and we are going to have cell nth of type, and we're using nth of type because this style is a sibling of the cells and is right before them, so it's going to mess up the index of nth child. So here we're going to have every n cells plus I, and we have plus 1 there because the nth of type index is 1 based as opposed to the loop index, which is 0 based. And here we're going to set the column index to the loop index, and we're going to have something very similar for the row indices. So we're not going to go every n cells, we're going to go after all the cells on the previous rows, and the row index is going to be j. Okay, and now we can move back to the CSS and compute a few things first. First off, a middle index, and this is basically going to be the average between the first index. So let's say that we have the same number of rows and columns, so it's going to be the same value for the middle index for the columns and the middle index for the rows, because we have the same number of rows and columns. So let's say that we consider the columns. This middle index is the average between the index of the first column, which is 0, and the index of the last column, which is n minus 1. So that's 0 plus n minus 1 over 2, or it can be 0.5 times n minus 1, 0.5 times n minus 1. And now we're going to compute the difference between this middle index and the current cell index. First for the columns, so we're going to have difference I, because I is the column index and j is the row index. And here is going to be m minus I. Right, and then we're going to compute the absolute value of this difference, which is I, which is going to be the maximum between this difference and its additive inverse, which is minus 1 times. Okay, and then we can also compute the sign of this difference. So this sign is going to be a clamp, minus 1, and 1 is going to be the maximum. And in the middle, the thing about this difference is we're not sure it's an integer, because we're not sure m is an integer. I is always an integer, but m may not be an integer. This depends on the parity of n. So if n is odd, then n minus 1 is going to be even, and multiplied with 0.5, which is the same as dividing by 2, is going to give us an integer. But if n is even, then n minus 1 is going to be odd, and divided by 2 is going to give us something 0.5. So we don't have a guarantee that this difference is always going to be an integer. It may be something like 0.5. So in order to make sure we only have integers here, we're going to divide this by 0.5. We're going to divide that difference by 0.5, and this is going to give us the sign. Now we're going to do the exact same thing for the rows, except we change the index, because the row index is j, the column index is I, the row index is j. So we change I into j everywhere here. Okay, now having done this, we are going to use those signs to compute the center of those circles first off. So we're going to have circle right here at, and here we're going to have calc, and we start from the middle, 50%, right? And then we have 50% times the sign along the columns. So this is the horizontal. And you can see right here, so we have 50% plus, in this case, the sign of m minus everything up to here. So this is the column with index m. So every difference between m and the column index up to here is bigger than 0. Here the difference is 0. So you can see that basically the sign is 0, and we have 50% plus 0%, because 50% multiplied with 0 is 0%. So there we have the center right in the middle, but here we have the sign is plus and we add another 50%, so we're going to have 100% horizontally. And here we subtract 50% because the sign is -1, and we're going to have 50% minus 50%, which is going to give us 0. And the exact same thing goes for the rows. So only thing that changes is we have sign j. That's all that changes. So you can see now how it's starting to look much better. Okay, now we're also going to use the stuff for the delay. And the thing about these absolute values, they're always between 0 and m. Now, you know that there's 0 right here, because here the column index equals m. It's right in the middle. And here the column index is 0, so m minus 0 gives us m. And here the column index is n minus 1, but m is half of n minus 1, so the absolute value of the difference is going to be m. Okay, so these absolute values are between 0 and m. And if we divide them by m, then we get something between 0 and 1. And if we add up these two ratios that go between 0 and 1, their sum is going to be between 0 and 2. But if we want to reduce it to the 0-1 interval, we divide the sum by 0.5. So that's what we'll be using for the animation delay. So animation delay, we're going to have calc 0.5 times, and we can take out the over m part from the ratios, so we can take it out of the parentheses. So over m, and here we're going to have the absolute value for the columns plus the absolute value for the rows, and then everything we multiply with the animation duration t, and we should start seeing the delay. You can see it now, but we want the animation to be started for all our elements. And since we've just discussed that this value right here that I've highlighted, selected, is between 0 and 1, in order to make all the delays negative, we just need to subtract 1 from that. So now it's going to look like this. And also you can see that the colors change abruptly between them. So let's fix that as well. We're going to have, again, keyframes, and we're going to have the first color scenario. So here we're going to have color, and this is going to switch to the second color in the list. And again, copy paste and change this. This is going to be background color, and this is going to switch to the first color in the list. And now we are going to have that first animation twice, the animation duration. We're going to have steps 1 infinite. If I could type, that would be great. And then almost the exact same thing for that C1 animation, and let's see it. Much better. Let's also add a gap right here. So we're going to have a grid gap, and we want it to be pretty small, so let's say something like 2 pixels. Okay, and now we can increase the grid size, let's say something like 15, and you can make it even bigger if you're on a better machine, but I'll just leave it at this. I won't be tweaking this any further. I hope you've enjoyed this video, and if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, then there's the option of a one-time donation, or you can make me happy with a gift off my wish list, or you can at least share this to show the world what can be done with CSS these days. Because honestly, I think it's pretty damn cool. In any event, thanks for watching. Thanks to everyone who has supported me in this year since I've started making videos again. Thanks for everything. You'll find the links for everything in the description, for the finished demo, for any resources that may be useful, for the inspiration, for my Patreon, for the one-time donation, for my Amazon wishlist, for everything. Basically, everything is going to be in the description. And I'll see you next time. Bye.